use all 8, but we can have 0 through 7 pre-done. I'm going to do the same 0 through 7 on the inputs. Now, so far, how I'm wiring it, output 0 is going to be the compressor relay. Output 1 is going to be gripper close. And output 2, I'm sorry, these are only 2 position, they're spring return, so it's only 2 outputs. So output 0 is going to be compressor relay. Output 1 is going to be gripper open, because when it defaults and we lose power, it's going to force it to close. So even if it's already there, we're going to turn it on to open, and when power's lost, it stays closed.
Right.
So if it already has something, it won't open and drop it.
Right.
That'll be a safety feature.
Yep.
So that's all we really have for outputs right now. I don't know what else we're going to have. We'll probably need more inputs, but I'm only going to wire the first 8. If we decide we need more, then we'll come across and we'll do all 16.
Okay.
So
now, you're going to use, how are you going to communicate with the robot and from the robot to the PLC here?
So that's going to be another output input generation.
Okay.
So we'll have to send an output from the PLC over to the robot inputs saying, all of my conditions are met, you can continue. So it's looking for one of its inputs to go live to continue the program.
So basically
and when it says it's completed the section, it's going to energize one of its outputs. And that's going to send something to PLC and say, hey, this is done, you move on with your program. And then when it completes its part, it says, I've done everything I need to do, it's your turn again.
So we're going to use the robot controller as like a subroutine controlled by this PLC.
Yes and no.
Yeah, in a sense, yeah.
They're basically going to be handshaking the whole time.
Right.
So there's a machine I have at work. We have a Taiwanese CNC with an American-made pallet changing system.
Yeah.
So we have to make them talk, and so when the CNC does a certain function, it sends a command over to that item and says, hey, this is where I'm at right now, and I need to do this. So I'm going to go in pause mode, and then you send me a signal when I'm allowed to move again.
Yeah.
So it goes through all its stuff and does everything. The pallet changer does its thing. Machine moves, pallet changer does more stuff. It says, hey, I am done, I'm hands off, you have control again. The machine goes in, runs its program, comes back and says, okay, I'm back in my spot where you need to do work. So basically that's what's going to happen here.
Okay, so the last line of a portion of this program is going to be like almost like a jump subroutine to the robot controller, and when that's finished, it'll jump back.
Yes and no, because basically what's going to happen is when the robot gets to a certain point and it needs something from the PLC to operate, it's going to be looking for one of its inputs to go live.
Right.
So we'll generate an output, and we'll make one of the discrete outputs on the robot energize. When that happens, that's going to go through and it's going to hit an input, and that's going to come up into here, and the PLC is going to go, hey, that input's on, that means the robot's at this point, and I'm at this part of the program, so now I can actually continue with what I need to do, and it's going to go through all its steps, whatever it requires, and then it's going to get down to the end, it's going to energize an output, and then the output, an actual physical output, is going to turn on, that's going to energize and go back up to the robot. The robot says, okay, that output's energized, I'm ready to move on. So it's not really subroutines and jumps. But it is, but it isn't.
It's almost, to me, it's a lot like a soft and hard jump.
Yeah, you're just basically making, in essence, two controllers talk to each other, and this controller controls this half of the function, and this controller does this half of the function.
Yeah, and you use a hardware link to communicate, like a translator.
Yep. So I'm not quite sure yet how we have to do all the safety stuff. That's going to be, I want to see if I can schedule. We can't get Ed next week, but I don't know if the guy from tech support can come in here or if he's just going to be an over-the-phone guy. But I want to see if we can get him or Ed. If Ed can't come next week because he's on vacation the following week,
yeah,
I want to see if he can get in here. And I just do not understand these controllers and how they work. So
okay,
I got to do a lot of studying on those. I need the model numbers off of them so I can.
Yeah. Real time now.
All right, cool. So, got a generic test program running. Brake the curtain to prove that it stops. Does not restart on its own. Over, hit start, and it continues from where it left off, knowing where it needed to go. As long as power is not lost, it should pick up right where it left off. So it's a hard pause that needs a physical restart. So, awesome. All our safety circuits work. Yeah. This thing is now actually safe. And just so you know, we're using a bypass key if you notice the door's open.
Yeah, bypass key.
It's a bypass key for troubleshooting purposes. You can't troubleshoot, you can't bypass freaking light curtain.
Yeah, it might get a little uneasy if he.
You can do it, and it's tricky.
Yeah.
Because it takes some funky wiring, but you can bypass it. The old ones used to have a control box. You could put a key in, you could actually go into a bypass mode and you can ignore them.
We got some of those that work.
But those are old. I don't think they have them anymore. Now you actually have to jump wires all over the place to get it.
It might be a code violation.
It is now. The way they make safety circuits, because businesses were just throwing in bypass all the time instead of just cleaning the lenses.
Yeah.
I mean, it was that simple. So, but I like it. Now, one question I have. Doors open, throws the e-stop. So that also stops it.
That is awesome.
Resets. Creates the e-stop. That'll turn the servos back on. Display change. Program test. Start. Off she goes again. That was what I was missing. I